students, Mr. Murphy, Lesson 5, Module 5, Graphs of Functions and Equations. So if we define a graph of a numerical function to be the set of all points where x is the input and y is the output. So first of all, functions don't have to be numerical, but if they are, if numerical functions, then they are described as an equation, then the graph of the function is the graph of the equation. So if I have a numerical function, it's basically an equation, and the graph of that equation is also the graph of the function. But we want to look at more than just that. So we know equations. We know this is a linear equation. If this was y equals 3x minus 4, then I know that my y-intercept is 0, negative 4, and I have a slope of 3. So I go up 3 and over 1, and then I can draw a straight line. And I know it's a straight line because there's no exponent here, or technically the exponent is 1. Okay. I can put a number negative 2 in for x. That would be 3 times negative 2 minus 4. I could put a negative 1 in for x. That would be 3 times negative 1 minus 4, and I would get a 7. I can put a 0 in, etc. I can build a table, and I can build a graph from my equation, and that equation is exactly the same as the function. So the function would have the same graph and the same table and the same graph as the same equation. Okay? But we are moving on from just linear equations, just straight lines. We can also have curves. So the function of x, where x is squared, is the equation of y equals x squared. So if I put a negative 2 in for x, negative 2 times negative 2 is a positive 4. So I have negative 2 and positive 4. If I put a negative 1 in for x, then negative 1 times negative 1 is positive 1. So I have negative 1, positive 1. A 0 times a 0 is 0, so I've got the origin 0, 0. And if I put a 1 in, 1 times 1 is 1, so I have the point 1, 1. And if I put a 2 in, 2 times 2 is 4, so I have this. So these points actually kind of line up for each other, and I have what they call a parabola. Okay? So if linear equations and linear functions have an exponent of 1 or 0, that makes a straight line. Then when I have an exponent that is greater than 1 or not 1 or 0, then I start getting curves. But each curve is slightly different, right? If I put x to the third in there, I get this blue curve in the middle. If I put x to the fourth in there, I get kind of that parabola with a flat bottom. If I put in x to the fifth, I get like x to the third, except this is a little bit more flat in the middle. Okay, and there's a pattern like that. The even numbers will be these parabolas, and the odd numbers will be these like steps. Okay, but functions and equations run basically the same way. So if I want the function for Giselle's running when she runs 3 miles in 21 minutes at a constant rate, well, I know that constant rate means I'm going to look for a proportion y equals mx, where m is the proportion of 3 and 21. Okay. So let's take a look at that. To write that, we start out with, x and y, right? If x is time and y is distance, then she runs 3 miles in 21 minutes, or it takes 21 minutes to run 3 miles, then I can say y divided by x is 3 divided by 21. 3 divided by 21 is 1 over 7. If I multiply both sides times x, these x's cancel out, and I have y equals 1 over 7x. Okay. So we've created an equation from our word problem. We're going to take that equation and use it to answer questions. So how many miles can she run in 14 minutes? So x is the time. So I replace x with 14. 14 divided by 7 is 2, so she can run 2 miles in 14 minutes. I can create a table for this. So x is minutes, y is miles. So 1 mile in 7 minutes, or 7 minutes to run 1 mile, 14 minutes to run 2 miles, 21 minutes to run 3 miles. And I've just been putting them in this equation. And I just basically did it backwards and said, if I put a 1, then I have 1 and 7. If I put a 7, I'll get 7 times 1/7 is 1. I'll put a 14. 14 divided by 7 is 2. So I just put powers of 7 in my x because I knew that would give me nice whole numbers coming out the y. Then I can graph it. So if the x is 7, I go over 7 and up to 1. If the x is 14, I go over 14 and up 2. So that's 14, 2. That's 7, 1, etc. And then I draw the lines in between. So I have a graph, a table, and an equation of the function for Giselle running, which is exactly the same as the equation that Giselle was running. So basically what I'm saying is equations and numerical functions are basically the same thing.